everyone, today we'll be looking at module 2 for data science, in which we'll be learning about structured query language, also known as SQL. So first let's look at why SQL is essential for data science. SQL is really useful when we learn data science because it's efficient. It helps us prepare data for data analysis, and it's easily integratable with existing software like Jupyter Notebooks and Python, and it helps us access data in a fast and efficient way. So now let us look at some SQL commands to create and modify and access data. First, we'll look at creating a table. The syntax to create a table is create table, the two keywords, followed by the table name, open the bracket. In the bracket, we enter the different columns and their data types separated by comma. We have column 1 and then the data type and how many ever columns we need, and we close it with a semicolon. Let us now look at a practical implementation of this on MySQL Workbench. Firstly, let's create a database for us to store all our tables. The keywords to create a database is create database followed by the database name. That's it. To run this query, I click on the lightning icon, and as we can see, the query has been successfully executed. Now we need to tell the application that we would like to use this database. So the keyword for that is simply use. So let me run this query as well, and this query has been executed successfully. Now let us create a simple table. Create table, the keywords. Table name is students. We'll have 4 columns. First column is student ID. The data type will be integer. Next, we'll have the student name, which will be of text type. For text type, we use varchar, which means variable character. And in the brackets, we give the maximum length of the string. Next, we'll have age, which is also an integer. And next, we'll have marks, which is also an integer. Finally, close it with a semicolon, and each of the columns are separated by a comma. So let's run this query. We have created the table successfully. Now we also insert records into the table. To insert records, we use insert into table name, the keyword values, and then the values which we want to enter. Let's implement this. Insert into students, values, and the rows which we want to enter. So each row is entered inside a single set of brackets. In the brackets, we'll give the column values separated by comma. So we have student ID. So we will enter student ID first. This is our first row. Student ID is 101. Name is, enter the name, age, and then marks. Now this is one row. Suppose we want to insert multiple rows. Just a second. This is the syntax to insert one row into the table, and this has been executed successfully. Now to insert multiple rows into the table, we use comma again to separate the different rows. And finally ending with semicolon. So when we run this query, 2 more rows get added into our database, into our table. The next thing is select statement. Select statement is used to display all the data in the table. The syntax is select star from students. Star is used to indicate all columns. So when we type this into our MySQL Workbench, the entire table gets displayed as shown here. We also have various additions and conditions and subclauses we can add in the select statement, but we will look at them as we move further into the lesson. The next SQL command we have is the update statement. update is used to modify existing records in a table. The syntax is update table name, what we want to set the value of which column, where the condition. Let's look at this example. So we are updating students. We are setting the age as 21, where the marks is 85. Because we have marks as 85 and we have name as Usha. So we want to update the marks and age of Usha. So we use where clause. So when I run this query, it gets updated. And when we check the table again, we can see that Usha's marks and age have been updated. This is the use of update statement to update any records in the table. Next, we look at the delete statement. Delete is used to remove records from a table. The syntax is delete from which table we want to delete, where condition. Same as the update one, here we will just delete from the table directly. So let's use this delete statement. Delete from students, where let's delete student ID equal to 103. So we're deleting the last record. So when I run this, it gets executed. And when I check the table again, that record has been deleted and there are now only 2 records left in the table. This is the use of delete statement. Next, let's look at basic statistics with SQL. The average of the dataset is calculated using mean. The function used for this is average, AVG. We also have the function to calculate the mode of the data set. We will group by whatever column we want to group and then we will order by the count. Count is basically used to give you the frequency of Now let's look at data munging with SQL. Data munging or data wrangling is the process of transforming the data. So data is not always consistent. It may have uppercase values or lowercase values or some inconsistent formatting. To normalize the data and make it easier for data analytics, we use data munging. Okay. Now let's look at this example. Here we have the initial table where the marks of Meena is recorded as null and Ravi has been duplicated twice. So there are 2 rows containing Ravi. So after we conduct data munging, we remove the duplicate row and we assign marks to Meena. So this is the process of data munging which handles duplicates and missing values and other inconsistencies. So the functions used to do this data munging is upper converts the given string to fully uppercase letters, lower converts it to fully lowercase, trim removes the space on either side of the string from the starting and ending. So this space is removed in the output. Ltrim is used to remove the excess space from the left side. Similarly, rtrim is used to remove any unnecessary spaces on the right. Now the function write is used to return the number of characters from the right end of the string. So here we have select right. Welcome to data science 7. So we want to select the last 7 characters from the right of the string. So when I execute this, I get science. Similarly, we have a left function which is used to select the n number of characters from the left side of the string. So when I run this, I get welcome, which are the 7 first letters in this string. Left, and we have replace. So let's look at an example for replace. Replace is used to modify a substring in a string. So look at this example where the phone numbers given here have hyphens in them. So the hyphens need to be removed in the final output. So to do so, we use the replace function. We give select this replace which column, the phone number column. We want to replace hyphen with empty string. So once we give this command, we get the output in which there are no hyphens in the phone number. Let's try this with an example in our own table, students table. So we have student ID. So let's try modifying student ID. Let's select name, comma, replace. Let's replace 1 with 2. Suppose we want to convert the ID from 101 to 201. Then we replace, let's replace 0 with 2. Suppose we want to convert 101 to 121. Then we use the replace function. So let me run this query. Yes, so it has been replaced. Now let us move on to the next topic, filtering, joins and aggregation. Joins are the commands that are used to combine rows from 2 or more tables. There are many types of joins, but the 4 basic types are inner, left, right and full join. So the inner join combines the two tables based on the common rows. The left join combines all the rows of table 1 with whatever is found in table 2. Right join combines whatever is there in table 2 with the only the common ones in table 1, and full outer join combines both the tables, all the rows together. So let's consider these two tables, employee table and department table. So we want to do an inner join between these two tables. We have ID and state in employee table, and we have ID and branch in department table. So when we do an inner join, it finds the common rows between the two tables and the output is shown. As we can see, only 11 and 12 are in the common inner join because 10 and 13 are unique to each of the respective tables. So inner join finds the common rows and displays them. Left outer join combines all rows of the left side and matching rows in the right side. Looking at an example, the same two tables, 10, 11, 12, all of these are from the left table. And since right table only has 11 and 12 common with employee table, it is shown in the final output. Similarly, right outer join. Right outer join combines the department table with only those common in employee table. So department has 11, 12, 13, whereas employee has only 11 and 12 in common with that. So in the output, we can see we have 11 and 12 and 11, 12, 13 from right table respectively. Full outer join is used to return all the records that have a match in either of the tables. So when we run full outer join, we get 4 rows, which is 2 into 2 from both the tables. So we have 10, 11, 12 from the left table and from employee table, and we have 11, 12, 13 from the department table as well. Moving on to aggregation. Aggregation functions are the type of functions which can be performed on a group of rows. These consider the entire table and they give the necessary value based on a set of rows. The first function is count of something. The count function returns the number of values. So let's implement that in our students table. Select count star. Star is for all columns. Select count star from students. So this will tell us how many columns are there in students, and we have 2. Now, if we want to rename this column and make it look better, suppose in a formal report, we use the keyword as, and then we enter what we want to name the column as. So I want to name my output as total. So when I run this, the output is displayed as total with the placeholder which I just entered. Next function is average function. So suppose I want to find out the average of the marks of the students. I enter average avg of marks as average underscore marks. I execute this function and the average is displayed in decimal points. The next aggregate functions include sum, minimum, and maximum. Let's visualize and execute all of them. So I want to find the sum of the marks, the least marks obtained, and the maximum marks obtained as well, all from students table. So when I execute this, all 3 of our values are displayed: average marks, minimum, and maximum. So these are some of the aggregate functions. Next, we move on to filtering. Filtering is used to remove redundant and useless data and make the data set more efficient and useful. So filtering includes where clause. Where clause is used to implement a condition. Suppose we want to implement equal to, we enter the column name equal to expected value. Let's look at an example. So suppose we want to select from students where student ID is equal to 101. When I run this, I get only one column because there's only one student with the key with the student ID 101. We can also use the operators like greater than, lesser than, greater than or equal to, lesser than or equal to, and not equal to add more conditions into the where clause. So suppose I want to find out the students who have marks greater than or equal to 80. When I execute this query, again I get only one row because there's only one student with marks greater than 80. Suppose I want to combine two conditions, then I can use the AND keyword. So let me do this here. Here we will get no output because we don't have any rows which have marks greater than 80 and student ID equal to 101. But if I set it as 102, then I would get 80. Student ID 102. This is used to combine two conditions. If we want either one of the functions to be true, we can use the OR keyword. OR keyword is used to display any one of the conditions, the rows which have fulfilled any one of the conditions. So let me do this. So here we can see both rows from our table are being displayed because one of the rows has marks greater than 80 and one of the rows has student ID equal to 101. Next, we move on to window functions. Window functions are usually applied to a set of rows. Window functions are applied to a group of rows rather than just a single row. First, let's look at the order by class. This is used to sort the data in ascending or descending order. Let's implement this to our students table. Let's order by marks. Default mode for this order by clause is ascending order. So here it's displayed in ascending. If I give the keyword DESC for descending, then the marks are displayed in descending order. Next, let's look at the rank function. Rank function is used to assign the position of any row according to which we partition. The rank function Next, we move on to NoSQL databases. These are basically databases that support unstructured or semi-structured data. NoSQL databases are really useful when handling large amounts of data because they follow the four rules of basically available, soft state, and eventual consistency. So these are used when we don't need tables to store the data, and it is flexible and fast, and it's mostly open source. First, we have document databases. Document databases store the data in the JSON object format. Each document has key value pairs. Key value pairs means, like a dictionary in Python, it's indicated between curly brackets. The key is the part before the semicolon. This is the syntax. Key value. So an example of this would be name. So here name is the key and Ravi is the value. This is how data is stored in document databases for data science. Some examples of this would be MongoDB and CouchDB and many more. The next type of database is wide column database. It stores the data and records, but it can also store a large group of dynamic columns. So the columns can be in any format and it can be stored inside the database. So this is used when we don't want to have multiple tables. We can just have multiple column families. This is the example picture given. Here we can see that we have defined a super column, name and value, and they are being used in multiple places like user and order. They are being used. The next type of database is graph database. It stores the data in forms of nodes and edges. So like how we draw a graph in graph sheet, we mark the points and draw the lines. Data is similarly stored in the form of nodes and edges. An example of this would be storing address, friend. So the node represents the value while the edge represents the relationship between the two nodes. So here we have ABC is a friend of XYZ. This is how data is depicted in node-based databases, graph-based databases. Let us look at a few more commonly used SQL commands. Let's create a new table named department, which has department ID integer. Now we learn a new thing called a primary key. Primary key is the column which will be used to identify each row in the table uniquely, and primary key cannot be duplicate and cannot be null. These are the constraints which primary key should follow. The next column we'll have is department name, and we'll set it to a string of 30 characters. We will add a constraint to this called unique. We can't add any duplicate values which have the same department name. So suppose I have a record which has department name as IT. I can't add another row which has department name as IT, because department name column has a unique constraint to it. So let's create this table. The table has been created. Now let's create another table, employee. Let's create first column will be employee ID integer. This will also be a primary key because there is only one employee with one employee ID. There can't be two employees with same ID because then it would be duplicate. Then we have employee name, which is again variable character type of length 30. Now let's set a constraint not null. Not null means that if we insert a record into the table with this specific constraint, the value of this column cannot be null. So suppose I am entering a record with employee ID 101. The name cannot be left null. There has to be a specific value for the name. So this is what the not null constraint allows the user to do. Next we have email. Let's also set email to be unique. We've already seen the unique constraint in the department table. Next, let's set salary. For salary, we'll use a new data type called decimal. Decimal has two arguments, the number of digits before the dot and number of digits after the dot. So here we'll set 10, 2. So essentially there can be only 2 digits after the decimal point. This is what decimal 10, 2 specifies. The next column we can set as city with again varchar of 30. A new constraint for this is default value. So if suppose the user enters a row in which this column has no value, then it will resort to this default value as entered here. So we want the default value to be Chennai if the user does not enter any value for that. The next is department ID integer. Now remember, we created a department ID in the department table. So we want this department ID to be the same as the one in the department table. For that we use a concept called foreign key. Just like how primary key is used to identify a row in that own table, foreign key is used to identify a row in the other table. So we want this department ID as the foreign key. We want it to refer to the table department. And which column in department? Department ID. So what this foreign key is doing is, it is creating a foreign key in the column department ID, and it's referencing the department table. In that department table, the department ID. So when we create this, department table has been created. Now let's insert some values into department. We'll enter we have only two columns, which are department ID and department name. So now let's try entering some duplicate values into the department table. So here I have two rows which have same department ID, and if you remember, we defined this column as primary key, which means it has to have only unique values and no duplicate values. So when we try to insert, we get the error as duplicate entry for this key. So now we change the department ID, and let's insert another one. Now we also created a constraint for the department name, which said that had to be unique. So it can have only one type of the department name in the entire table. There can be no duplicates. So let's try inserting that. Let's insert IT again. So when I run this query, I get another error, duplicate entry for IT. So since IT is a duplicate value, it doesn't allow us to enter that row. So let's enter these 4 rows into the table. Now let's insert some values into the employee table. Okay. Now in the employee table, we added a lot of constraints. So first let's violate the not null constraint which we added to the employee name. So let's leave that as null. So we are entering a null value instead of employee name, and let's enter dummy details for the rest. And let's also leave the employee name. We get an error saying null values cannot be inserted. Now to insert specific values into the table, we specify the column names in bracket. So suppose we want to enter only ID and email, then we specify those in the bracket and we enter that values which we want to enter. So when I try to insert, employee name doesn't have a default value, which is occurring because of the not null constraint we imposed on the employee name. So let me add. Now let us test the unique constraint which we imposed on the email column. So I am inserting this record into the table, and this email already exists in our table. So we should get an error saying email already exists. Yes, duplicate entry for key employee.email. Now the next command we'll be looking at is alter command. Alter command is used to modify any column or row in the table based on our conditions. So let's add a new column using alter table. The syntax for alter table is it has to include the keywords alter table and then the table name. Let's add a new column, phone, with 15 digits maximum. So we use the word add, added. Now we want to modify the phone column. I want to increase or decrease the length of the phone column. So I use the keyword modify and then I reduce the digits to 10. And when I run this command, the phone number gets modified. Now suppose I don't want this column anymore. The database is getting very big, so I just drop. I just want to drop this column. I use the keyword drop column and then the column name. And I run this query, the row gets dropped and it is removed from the database. The next
The
command
next
we'll be
command we'll
looking
be
at
looking
is
at is
update.
update.
Update is
Update
used
is used
to
to
update the
update the
value
value
of
of
any
any
specific row.
specific row.
We can
We can
update
update
the value
the value
using where
using where
condition.
condition.
So let's look
So
at
let's
an
look at an
example.
example.
Update
Update
employee.
employee.
We want to
We want to
change the
change the
salary
salary
of
of
the
the
person
person
whose
whose
employee
employee
ID is
ID
1.
is 1.
So it
So
gets
it gets
updated.
updated.
When we
When
look
we look
at
at
the
the
table,
table,
we can
we
see
can
that
see that
it has
it
been
has been
updated.
updated.
Next we
Next,
want
we
to
want to
delete.
delete.
Delete
Delete
from
from
employee. The
employee. The
syntax
syntax
is
is
delete
delete
from
from
table name,
table name,
and we use
and
the
we use the
condition to
condition to
delete any
delete any
specific row.
specific row.
So I want
So
to
I want to
delete where
delete
the
where the
employee ID
employee
is
ID
2.
is 2.
So the row
So the
gets
row gets
deleted,
deleted.
and
And
when we
when we
check the
check the
table
table
again,
again,
we
we
can
can
see that
see
the
that the
row
row
is
is
not there.
not
We
there.
have
We
only
have
1
only 1
and 3.
and 3.
Now suppose
Now
I want
suppose
to
I want to
drop this
drop this
entire
entire
table.
table.
I don't
I
want
don't
this
want
table
this
to
table to
exist anymore,
exist
and I
anymore, and I
decide to
decide to
drop it.
drop it.
It gets
It gets
deleted. The
deleted. The
syntax
syntax
is
is
drop table
drop table
table name.
table name.
Now let's do some SQL commands on the department table. Now these are the rows we have. Let's add a new column using alter table command. We want to add a new location column which has a data type of 30. So edit, and it's added to the table. The next thing we'll do is we'll set the location for the column. We'll set the location as Chennai. Set the location as Chennai where department ID is 101. Similarly, we can do the same for all the departments. So we've set a location for all the departments using update. All 4 rows have been updated. So if we look at the table, we can see that the changes have been reflected. Now we will look at adding a constraint to the table. So first for that, let's create another new column, budget, which will be a decimal. 10 comma 2 indicates 10 digits before the decimal point and 2 after the decimal point. Let's set the same budget for all tables, I mean for all rows. Now let's add a constraint to this budget table. We use the keyword add constraint, and then we name the constraint. We are adding check underscore budget, and we need to check if budget is greater than 0. This is the constraint. The name is check underscore budget, and we are checking if budget is greater than 0. That's it. This is the add constraint budget. The last topic is subqueries. Subqueries is basically a query within a query. So let me show an example. Department where budget. Now we enter the subquery in the where clause inside brackets. We want to select the average budget from department, and now this query will select the average budget from the table, and this outer query will return all the rows where the budget is greater than the average budget. So when we return this, none of the rows are displayed because all of the rows have the same budget. If you use greater than or equal to, all rows will be displayed because average is equal to the budget. So yes. Another alter function would be renaming a column. We use the keywords rename column and which column we want to rename to what column. Once we click this, changing department ID to ID, and when we check this, we get the changes reflected. Efficient way to learn SQL is to use the W3 Schools website, which has a systematic order of SQL courses. First, we have the syntax select, where, order by. It also has in place practice boxes where you can enter the code and try it yourself and see the output in real time. So, W3 Schools is highly recommended. And they also have a quiz at the end of every chapter. So, to get proficient in SQL, students can use W3 Schools. Now, an important aspect in SQL are the types of commands. We basically have 5 types of commands, which are DDL, DML, TCL, DQL, and DCL. First, coming to DDL, which is data definition language. These are the commands that define and alter and delete the structures like tables and indexes and databases. Some of DDL commands include create, drop, alter. We will be looking at these commands in detail further. The second type of commands is data query language, DQL. This is used to fetch data from the database. The main command is select, and we have more subclasses like from, where, group by, all of these which are used along with the select command. So the main command is select in DQL. The third type of command is data manipulation language, which is DML. These are used to manipulate the data which we have already stored in these database tables. Examples of these include insert, update, and delete. Since they manipulate the data, they are called as data manipulation language. The other 2 types of commands include data control language and transaction control language, but we will be looking at only DDL, DCL, and DML in detail. Group by command, which groups certain rows together. Let's select location count as total departments from department table. Group by location. So when we run this command, we can see that we have the location and the count of the number of departments in that location. So this is what group by is used for. Next, see the having by clause, which is which is used along with the group by clause. So if we'll use having along with the group by. So to show the groups which have count more than one, when we execute this command, we have Chennai 2 because it has 2 departments in Chennai. And lastly, we have partition by. So let's select department name, location, and budget rank over partition by location, order by budget descending in descending order. We'll name this as department rank from department. So what this very basically means is rank assigns a rank to each row. Over is used to define the window over which the ranking is performed. So the window in which we will be performing this rank operation is given by partition by and order by. Partition by divides the table into separate groups based on location, and order by budget descending orders them according to the budget in descending order. We name this as department, right? From department. So when we run this query, we get all of them as rank 1 because all of them have the same budget. So this is the use of partition by.